Now for step 6, we construct an ANOVA table. This is a collection of everything that we have calculated so far in the process of calculating the test statistic. And this is now our table. Now for step 7, we now formulate our conclusion. We now use our decision rule that since the F statistic of 4.2361 is greater than the critical F value of 3.4668, the result of the test is statistically significant. We reject the null hypothesis, stating that there are no significant differences among groups. We have sufficient evidence to show that there is at least one group mean which is significantly different from the others. In other words, the result of the test provided evidence that the surrounding environment has a significant impact on the ability to remember a list of words. We have also included a p-value approach to testing the significance of the result. In this case, the p-value associated with the test statistic of 4.2361 is 0.028475. Since this is less than the significance level alpha of 0.05, the result of the test is statistically significant. And so we reject the null hypothesis. It is important to note that the result of the p-value approach and the critical value approach are just the same. Both of them are statistically significant. When we conduct an ANOVA, or analysis of variance, it's like running a big test to see if there's a difference somewhere among the groups that we are comparing. In our case, the different surroundings, shopping mall, car simulation, and outdoor setting. The ANOVA gives us a thumbs up saying, yes, there's a difference somewhere, but it doesn't tell us exactly where the difference is. This is where the post-hoc test comes in. Post-hoc means after this. So after we've done the big ANOVA test and found there's a significant difference, the post-hoc test helps us figure out exactly where the difference lies. To identify the pair of samples that are significantly different from each other, we will conduct a Fisher's least significant difference test, or LSD. The idea of this test is we will calculate the least significant difference. And if the actual mean difference is greater than the LSD, we conclude that the difference is statistically significant. So using the LSD equation, we have the LSD, or least significant difference, is calculated as the product of the t-value associated with the two-tailed significance level alpha and the degrees of freedom for error, multiplied by the square root of the product of the mean squared error and the sum of the reciprocals of the sample sizes associated with the samples being compared. Now, examining this equation, we observe that the LSD value changes only when we alter the pair of samples for comparison. This change occurs if the sample sizes across the groups are not equal, as the t-value remains constant depending on the significance level and the degrees of freedom for error. The mean squared error is also calculated beforehand. Consequently, these values do not impact the LSD. Only the sample sizes do. Since we have already calculated the degrees of freedom for error, which is equal to 21, and we are given the significance level alpha of 0.05, we proceed to the t-table to determine the t-value that we will use for the LSD. In this case, we look for the degrees of freedom for error in the first column. We look for the value of 21 in this first column. And we have this value here. And next, we look for the two-tailed significance level alpha of 0.05 in this particular row. Here we find 0.05, and the intersection of this particular location and this will be our t-value that we will use for the LSD. So 2.0796. Now going back, we have the critical t-value of 2.0796. Now calculating the LSD between sample 1 and sample 2, we have 2.0796 times the MSE of 4.61 times 1 over 8 plus 1 over 8, we get the LSD of 2.2333. Since the sample sizes are consistent across all conditions, which are all equal to 8, we know that the LSD will remain the same. As a result, we can now compare the mean differences of each pair of samples and the LSD to determine whether the difference is significant or not. As a result, we have here we see that the mean difference between samples 1 and sample 2 is 0.375. So this is actually calculated from the sample means of sample 1 and sample 2. We have here the means of sample 1 and sample 2. So if we subtract the mean of sample 1 from the mean of sample 2, we will get 0.375. So for samples 2 and 3, 8.5 minus 11. So that's how we get the mean difference. So here we have 0.375. Now this is less than the LSD. So that is why the status is not significant. The difference between these two samples are not significant. Now for this one, samples 1 and sample 3, we have a mean difference of 2.875, which is greater than 2.2333. Same with this one. For samples 2 and sample 3, the mean difference is 2.5, which is also greater than 2.2333. And so these differences are actually significant. So the Fisher's LSD test revealed statistically significant differences between the means of sample 1 and sample 3 and sample 2 and sample 3. Be reminded that sample 1 is our mole condition, sample 2 is the driving condition, and sample 3 is the outdoor condition. So in this case, the mean of the mole condition is significantly different from the mean of the outdoor condition. In addition, the mean of the driving condition is also significantly different from the outdoor condition. For the APA format guide, a one-way analysis of variance ANOVA was conducted to assess the impact of different surroundings on memory scores. The results revealed a statistically significant difference among the three groups, with an F-statistic that is equal to 4.2361 and a p-value that is less than the significance level alpha of 0.05. Subsequent post-hoc analysis were performed to identify specific group differences. The Fisher's LSD test revealed statistically significant differences between the means of the mole condition and the outdoor condition, and the driving condition and the outdoor condition. The LSD analysis revealed statistically significant differences in the means and standard deviations across the identified pairs of groups. These findings provide robust evidence of distinct group variations within the overall significant effect of different surroundings on memory scores. These results imply that the different surroundings indeed have a statistically significant impact on the ability to remember a list of words. Specifically, the mean differences between the mole condition and the outdoor condition, as well as between the driving condition and the outdoor condition, were found to be significant. This suggests that the memory performance of individuals varies across these distinct environments. The observed differences highlight the importance of considering environmental context in studies of memory and cognitive processes. These findings suggest that the surroundings in which information is presented or learned can significantly influence memory recall. Understanding the impact of environmental factors on memory performance is crucial not only for cognitive psychology researchers, but also for educators and designers of learning environments. It implies that educational settings and strategies could benefit from tailoring approaches to leverage the cognitive effects of different environments. The results also emphasize the need for further exploration into specific mechanisms underlying the observed differences. Future research could delve into cognitive processes affected by environmental factors such as attention, encoding, and retrieval mechanisms. During the time of recording of this particular video tutorial, we have not yet included the calculation of the standard deviation as part of our calculation. So to be able to calculate the standard deviation for each of the samples, we can proceed to this menu bar over here and then search for descriptives calculator. And then we can type each of the samples individually. So for example, for the mole condition, we have 8, 7, 8, 6, 9, 12, 7, and 8. And then it's a sample, and then we calculate. And we will have here the sample standard deviation equal to 1.8077. And that concludes this solution. If you find this video helpful, please leave it a thumbs up Subscribe to this channel if you are not yet subscribed, and ring the notification bell so that you will be updated on our latest uploads. And as always, I'll see you on the next one.